take it away.
So thanks a lot. As the introduction said, myself and I have been responsible for various tools in the Erlang ecosystem. This one is just CutEr. Is really nicer. It's something that we have been developing for the last at least 2 years, and we have not publicized very much. This is actually the first talk on CutEr that is being given. And just this morning, we tagged the first version on GitHub so that we have something that people can refer to. So this is a bit of the overview of my talk, and since this is after lunch and people are tired, I decided to do quite a bit of demos as opposed to just presenting slides here. I hope that this will be entertaining and interactive. I very much encourage questions at any point. So this is a talk on testing. So CutEr is a testing tool, and I will briefly overview the options that one has in Erlang for doing testing, in particular unit testing, property-based testing, and of course Concolic testing, which CutEr is about. And then I will look at all the other things that you can read here. By the way, CutEr stands for a Concolic unit testing in Erlang. So without further ado, let me try to start by saying that testing is important. However, there are various people that don't like to do testing, partly due to the fact that it's in many respects a manual process. So one of the most commonly used frameworks for testing out there is so-called unit testing, which is started from languages like Java, and of course, since a number of years now, there is an e-unit system in Erlang also. So what e-unit testing means is that you have a program and you specify a number of units that you test, and you specify also the expected outputs that you get, and then you write using some language that you expect when you run these unit tests that you get these outputs. So here is a program that I have. So let me show it first here in a bigger font so that you can see it. It's a small function. It's supposed to take a list of numbers and then does some classification on the outcome of the sum of this list, of the elements of this list. If the sum is less than 0, then it returns negative. If it's less than my favorite 4-digit number, it returns small, otherwise it returns big. Okay, so I have this program here. So I can fire up the Erlang shell. I can compile it. Don't worry about the warnings. And I can say classify of the list with 42 in it. It's a small outcome. And classify this with minus 54. It's a negative. And with 5,400, it's a big. Okay, so I can turn these ones now into unit tests and use a unit testing framework to have them automatically run every time I want. But you can see here it's a bit of a manual process. Not very painful, obviously, because we have a very simple program, but a manual process nevertheless. Now, this is not the only type of testing that you can have in Erlang. In functional languages in general, but in Erlang in particular, there have been various tools that do property-based random testing. The Erlang Quick Check is one of them. Proper is another. Trick is another one. There are various frameworks, and they give you a way of having semi-automatic testing. So in property-based testing frameworks, what you have to do is you have to specify a property for the correctness of your program. So who could possibly help me here in specifying a property for this program? Anybody? John? Somebody else? Okay, so I will not keep you. Here I have a property. Here it is. I can take it also and put it higher so that this compiles. Here's my property. Doesn't show very well. It says that the classify function works okay if for all lists of numbers, then if I call classify on this list, then the result is either negative, small, or big. Okay, so we would hope that this property works. So I can now compile again this program, and I can run with my favorite property-based testing tool. The prop classify OK. So it passed 100 tests. I can actually run, say, 10,000 tests. It passes them. I can run 100,000 tests. It passes them. So I think I would, hope that now my program, my function works. It works for all inputs, right? As you probably guess, this function here has some errors. Okay, it actually has at least two kinds of errors. And to understand sort of the kinds of errors that this function has, you have to understand that actually what this function does is this. Okay, so the compiler inserts an implicit catch-all case clause here that will throw an exception if none of the other clauses match. And there are values for which the other clauses don't match. And you can very clearly see here, by the way, I can show you the same thing with any 4-digit number, or actually I can show you the same thing for any integer. There is an input that will make this function crash. So things that we note here for property-based testing is that it's a semi-automatic process. You have to specify a property manually. And actually, you get no guarantee that no matter how many tests you run, you have no guarantee that actually your function will never crash, your program will not do anything wrong. And this is where Concolic testing comes to play. Concolic testing, just in case you were wondering, it's not a word that exists. It's a made-up word, the word concolic. It stands from the combination of concrete and symbolic. And it does concrete and symbolic execution at the same time. So it's a fully automatic testing approach that aims to achieve very high path coverage. In principle, it aims to explore all possible paths that there are in the program. Now, of course, in big programs, this is a big number, so we need some way of actually exploring only some of them, but in principle, if you have enough resources, it can achieve complete path coverage. And path coverage is not just, so property-based testing or the other techniques of testing If you were lucky, they were only achieving edge or statement coverage. We saw that it didn't even achieve that in that particular case. Here we want to achieve path coverage. So let's see CutEr in action. And I will run, CutEr actually is a script. You can use it from Erlang, but it's much more convenient to actually use it from outside Erlang. And you specify the module that you want to test, the name of the function, which is your unit. Here it was classify. And then you give it a list of the arguments. And I have to use these funny quotes because it's a shell. And you have to give it some arguments as a seed. And actually, it doesn't really matter what argument you give it. You can give it any argument you like. But it's a good idea to actually give it an argument of that will make the function not crash, because otherwise you will see it in the crashing outputs. This one too. So as we saw with a list of 42, this function doesn't crash. So now I start this. And with the -r, I have to recompile this, and now it works. And it gives you a lot of outputs that will make the function crash. And the interesting outputs is, of course, this one. And at the end, it tells you, here are the outputs. This one is a very interesting one. If you call it with a list of 4, 7, 11, it will crash. This is another interesting one. Here, if you call it with a list of these two numbers, that if you do the quick math, you will see that they add to 4, 7, 11. And this is also an interesting one. If you call it with a floating point number, 4711.0, it will also crash. And a random property-based like testing tool will have pretty much no chance of getting this particular input to crash. Okay, so this is the point where I hope I have convinced you that there is something different going on here in the testing world than the other testing techniques. Let's see how this one is working. So concolic execution is sometimes known as dynamic symbolic execution. So the idea is we start with a concrete execution, and while we are doing the concrete execution, we collect some symbolic constraints on the program inputs that cause the program to follow a particular specific execution path. And then we use these constraints by negating one at a time to force the execution to go to some other paths. Okay? So by negating systematically these constraints, we will eventually explore all the paths. So that's what's happening here. So what's happening is that we do concrete execution and we collect information. We get accurate information about program state, which might not be easily accessible when we are doing purely symbolic execution. And that's why concolic execution tries to mix the advantages of both symbolic and concrete execution at the same time. So what's happening under the hood is that we are collecting so-called path constraints. So we collect constraints on the paths of the program. And each variable that depends on the input has both a concrete and a symbolic value associated with it. And we express path constraints in an appropriate logic. And then we use some SMT solver, technology that during the recent years has become very, very powerful to solve these constraints and generate new inputs that will cheer the future test runs to explore unexplored paths. So that brings a tree, and we systematically explore all this execution tree, up to a depth, of course, because in general, it might be infinite. We might have some paths that go into infinite execution, or the tree might be very big. So that's what's happening here. Let me show you another example, just to show you, to illustrate what's happening. Here is a variation of the previous one. We have a compare function that checks whether its result is greater, matches exactly or less than, whether it's greater, matches exactly or is less than 42, and returns an appropriate atom for that sort of thing. We have a fCompare function that has a sort of obvious error. It ignores the EQ case. And we have a higher order also function that takes a list and then calls list for each with the fCompare on each element of this list. And then we have foo. So let's see what CutEr will do on this sort of thing. The program is called SF2, and it's foo with the list of, say, 0. And why is there an error? You can see that it's a live demo. What is the bug here? So it finds erroneous inputs. 42 happens to be the star, so it prints them out as like that, but at the end you get the inputs that lead to the runtime errors, and you can see that all of them have 42 in them, which is the case that is not being handled by this program. Okay, so I just showed you this so that I show you how this one works underneath. There are various places where things can fail here. There is a place here that there is a failure. There is a place here that there is a failure. By the way, you can add explicit assertions at any point in your program, and CutEr will find inputs that causes assertions to fail if they exist. So if you see this program as control flow graphs for each function, you will see that, for example, there is a pattern matching compilation happening, and there are tests. So for example, the compare function, so the fCompare function calls compare and then checks whether we have a GT output or an LT output. Otherwise, it fails if none of them is true. So this is exactly the same representation, but in control flow graphs. The same for the list for each function. Notice that now I called also a function from another module, and CutEr automatically knew how to instrument this library and follow the control flow graph there. So actually, CutEr can handle the whole OTP pretty much. So what concrete execution is doing, it follows initially one particular path, the one that is shown with blue colors, and there are some unexplored paths that are shown in red colors. Okay, so we start with, say, the list containing 17 lonely, and of course, this list will match this cons cell, this pattern matching cons cell here, so we'll go to the true branch, and so on and so forth. So what's happening here is that we are following in concrete execution and we're checking constraints. And since we went with a true branch in the first time, the next time we should go with a false branch. We get these two constraints. These two constraints are as unsatisfiable. These are the x's you were seeing previously. Wherever you were seeing a dot, it found another path to follow. Whenever you were seeing an x, it found an unsatisfiable constraint. So the next one is more interesting. It says that we have as a constraint that the list is not empty and the head of the list is greater than 42. So we ask the solver, give us a value that satisfies this constraint, and the solver would say, try with 54. Okay? So we'll get something with 54 there. We have one more constraint here. It says that the list is not empty, the head of the list is not greater than 42, and the head of the list is 42. The only value that satisfies this constraint is the 42 value, and we'll get an error. So continuing like that, we'll explore all possible paths. So there are various things that are involved here. We need a search strategy, which decision node to reverse. And the tool uses two metrics. And I will not describe them here. But basically, it systematically explores all the possible paths that exist in the program. We also have a depth count that checks how many of these branches we will explore every time. And after that, we don't collect any more constraints from these branches. Okay. Now, this is the vanilla tool. The tool has support for type specifications, and actually it's a good idea to get types, to put type specifications in your program because it adds documentation, but it also helps CutEr. When I run, let me run it again to see what's happening here. The classify thingy. The tool was also showing some, it was showing some interesting test cases, this one, but it was also showing some test cases that look like this one. It says that if you call it with a list that has a float and the empty list, then this will crash. But obviously, and indeed it will crash, but you probably don't want this as an erroneous input. What you instead want to do is you want to write that in the same way when we wrote the property-based test that we wrote a generator here that this is a list of numbers, my classify function is supposed to work with a list of numbers and will return either negative or small or big. Okay, so now with this type spec, the tool will only find list of numbers, which is really what you want. By the way, I'm showing you the very slow version of the tool deliberately because you can run it in parallel. So for example, I can run it with 4 solvers and 4 pollers. And now we will run these things in parallel. And if you have a 64-core machine, you can play with this very nicely. Okay, so let's continue. So you can add type specifications like I did, and you will get the inputs that actually make sense and you are interested in. And of course, what's happening with these type specifications is that they impose, and you can make them actually as refined as you want. So for example, in the second program, I could say that this is supposed to work with a list of terms because I was having a list for each, or you can say that I wanted to work with a list of integers only. Okay? So you can make them as refined as you want. So what's happening is that if you add the specs, the type constraints that you have from the specs are added as part of the path constraint, so they prune the inputs that you are probably not interested in. This was the third demo, I think. Actually, I did it already. So let's do one more change. Let's do it a bit more interesting here. Let's put some more constraint. One more clause that will say that, hey, if I call the classify function with a list that has less than has 3 or less elements, then this is too short. Okay, so what do you expect that it will do now? Here's the program. Come on, it's easy. So it will only find erroneous elements that have lists of at least size length 4 and above. That's it. Ha! No runtime errors occurred. And this is because the default depth is very low. So I can increase this depth. I think it's 25, the default. Oops, no. I need a bigger one. Doesn't matter. So this is my favorite list that adds all its elements to 4, 7, 11. So you can see that it prints lists with size 4 first, then lists with size 5, lists with size 6, okay? I'll let it run and continue on the presentation. Here's another twist. I can write, since I'm a functional programmer, I can write lists sum this way. Will the tool be confused? By the way, it has finished and tells you all these erroneous inputs. So I can write lists fold L with fun Erlang plus and with 0. So will the tool be confused? Nope. It will find exactly the same things as before, okay? Trust me. And now the coolest of all. Here is a generalization of that program where we have 2 arguments, of the function. And the first argument is a function. And if we call now this with Erlang plus with arity2, this is exactly the same function as before. Now, what should the tool do here? What should it do now here, a tool that is supposedly sound? It so happens I have it here. Okay? Not exactly this. I can add the other. So I need to export this. And run it again. And now I have to give it here my favorite function. Let's say the function that only returns 0. I put it inside, I'm sorry. It generates functions that if you apply them recursively, they will return 4, 7, 11 of lists that are 4 and above. This is a wow feeling. If you want to make it even more interesting, here is the Y combinator. And it will return recursive functions that, if you apply them to a fixed point, you had a... Yes, it stops. Did. It always stops. Okay, so here's how it is underneath. It's actually, it has various components. The Concolic execution component that uses processes in the Erlang way and spawns various interpreters to do stuff. The path exploration component that has a scheduler and controls which thing will be explored next. And the constraint solving component that is using Z3 currently. Tool by Microsoft Research. But we are working on adding more SMT solvers. There are various technical things on how it works underneath, but I will skip this stuff. The tool is available on GitHub. It works for Erlang OTP 17 and 18. It has some limitations currently. It does not support maps. We haven't added the support for maps, but it's a technicality to do that sort of thing. It works for binaries. It works for higher order functions, as you saw. its support for recursive type is still incomplete. And we are working on that. Now, before I finish, let me show you, I've deliberately chosen small examples here, just to show the capabilities of the tool and make this talk understandable. But actually, this works on big programs. Okay, here is a real case. There is a post in the Erlang bugs mailing list last May, and it involved a module from the Erlang OTP RC1. Here is the post by Loic. Some of my applications don't compile anymore because they have been necessarily negotiated next protocol. Instead of the program is a crash in the compiler. So so happens that I have this program here. It's the OTP internal. But I have just renamed it to OTP int so that it doesn't clash with the OTP internal module in the OTP version that I'm using. You can see that's the real thing. It's 641 lines, and it has a bug somewhere. Where is the bug? CutEr OTP int. This actually is a very good case for CutEr. To tell you the truth, this is a very nice case for CutEr because it only has one exported function, so it's very clear which is the unit to test. Obsolete, it's called obsolete, and it takes 3 arguments, MFA. So what's your favorite MFA? Lists map with 2. I can recompile, and I can put 4 solvers and 4 pollers.
Can you just pass it types here?
Hmm?
Can you just pass it types here, or does it have to be actual, like, concrete?
No, you can put whatever you want really here. It doesn't matter. You will, if it's not, but you want to probably to put something that it doesn't crash, so that you don't see it also in the errors. Here it is. SSL negotiate the next protocol with RET1. If you call this OTP internal module with these inputs, this will crash. And actually, it's the only one. You will see that it will finish. So this one now does also gives you guarantees that up to that depth for search, there is no other bug in this module. So it will very soon finish. So will I. So here is where some concluding remarks. So I presented the Concolic testing tool for the functional subset of Erlang. And there is a tool that has just been tagged on GitHub with the first version, 0.1, but it's pretty robust by now. We have been working more than 2 years on this. Future work, what we are doing is we're doing better search strategies. We are experimenting with more SMT solvers, and we're trying to handle concurrency also. So Concolic execution just tries to do path coverage, but the interaction of processes is on a different level. So you need something that controls also the scheduler. We have quite a lot of experience in doing tools like that, but not in the context of Concolic execution. This is still going on, but believe me, it finishes in something like 1 minute or something more, something like that. And that's it. So,
Is that possible?
so this is a very good question, and this was something that I was prepared to also talk more about on Saturday, where I give a 3-hour tutorial on this. There is much more, obviously, than could fit the talk. This is a very good question. I will actually slightly rephrase it and give you another example, partly inspired by your talk. So we have obviously been using CutEr to test various things in the Erlang OTP system. And yes, there are some issues with strange types that contain semantic information. A good example is the calendar module. Okay, whoever designed the human calendar didn't design it with simple types in mind. So for example, you can have a very nice specification that says that the months are from 1 to 12, the dates are from 1 to 31, and the years are from 1970, you said, till now, or from 0 till infinity, or whatever. The problem is that not all of these combinations are valid dates. So in particular, 31st of February didn't even exist in the Swedish calendar that you described in your talk. So in those cases, just writing a simple spec, a simple type, is not enough. So what you have to do in your unit is you have to write these things as a case statement. So you need to write something that tells you which are the valid dates and write a wrapper around it and saying case valid date of true, my unit to test, else okay. Now, in those cases, you have to spend a bit of effort to describe the valid inputs and the non-valid inputs. Okay? There are cases where it's not, I mean, it is automatic, but you will get some inputs that they make your program crash all right, but they don't make sense. Or if you want your calendar module to also do something reasonable for 31st of February, you have to then change the code. Similar things happen, of course, with data structures. I mean, if you want a balanced search tree, you have to have a check that says case is balanced than this, otherwise not. And there is more to it. So the tool has also support for whitelisting various things. A typical example is stuff that have to do with logging. You don't want to search all paths in your logger. Okay, so you want to whitelist certain things. Yep.
So I have a question about the constraints of, so at least this tree is not really good with nonlinear constraints. So in your experiments, did you encounter nonlinear constraints? If so,
Well, of course, we have some nonlinear constraints. We have multiplication for it. I mean, we have various things that are nonlinear. Yes, of course, we have to take this into account.
so how do you model it? Do you use split vector or?
We can take this offline. There were some slides that say how the mapping is done, but we can take this a bit offline. I think it gets a bit too technical for us. Yep.
I saw that everything you did was on the command line. Is there some kind
Yes, of course, there is an Erlang version of it.
Okay, perfect.
It has finished, by the way. Yep.
Are there ways of meaningfully grouping the failing cases that it generates, either most simply by the site of failure within a unit or more sophisticatedly by the types that are going in? I mean, I'm thinking in your initial example, is there a way of segregating the empty list containing failure cases automatically from the pure numeric cases?
I haven't thought about it, quite frankly. I think you have to provide some extra information. And you saw that, for example, when you put the types, this disappeared. So without giving some extra information, the tool, just generates whatever the SMT solver decides to generate. You saw that some of these, lists were not exactly the ones that you would expect for 4711,
But you could at least see the site of failure. So say you were hitting two different bugs, and it was finding both of them. It could tell you these are the ones that hit here and these that hit here.
We know exactly where each of these failures occurs.
Right.
So we could separate them based on the program point that this would be very, very simple.
Right.
So in my experience so far, you typically start, if you get, you run with the default depth. Okay, if you get too many of these errors, you can just simply run with a smaller one. It will take actually less time to run. And you can eliminate those errors and then start with a bigger one. That automatically segregates the inputs. Yep.
Is there a way to designate a particular path you'd like to target?
Not that we have. This is on our to-do list. This is on our to-do list. I think it's obvious from the point that this is on GitHub that this is all open source, and you can contribute, you can post issues, you can do suggestions and stuff like that. Also, this is distributed with GPL, but this is not at all an issue because you absolutely don't have to put anything in your code base for this tool. This is totally offline. It's not even an include like in proper. I know that some people are worried about this thing. I never understood it, but I'm in academia. How should I know this stuff? Yep.
Have you found any bugs in CutEr using it?
We never write code with bugs. Yes.
So, Kostis, I guess if you were to apply CutEr to the Erlang compiler and ask it to find an Erlang program that crashes the compiler, it probably wouldn't work. But the scale is too large there. So, what's your experience? Where is the point at which things become too large scale? I imagine that this obsolete thing maybe has a lot of branching.
So actually, you are right. Of course, you are absolutely right. But actually, there are some other issues in applying it to, say, the Erlang compiler. We need to have an entry point that doesn't do file manipulation, for example. Okay, so we are actually applying CutEr to parts of the Hype compiler, which we know a bit better than the Erlang compiler. And there we are testing, modules at a time. We are not doing what you are telling me to do, and the reason is not only that the scale is so big. There are some other engineering issues involved in applying CutEr and saying, just test compile. This will open a file that will do other weird stuff that you have to define what your unit test. I mean, CutEr, the U stands for unit, and you are responsible to define what your test unit is. Okay, in that respect, the tool is not totally automatic. You have to tell me that this is my entry point, and everything below it So there is not an easy way of hooking to the compiler currently. Once we solve that, I think of course the scale will be an issue, but I don't think this will be the main. Currently, it's not the main issue. Once we overcome other issues.
I'm assuming we can on stuff, we can use Neck.
Yes. One thing that is not so obvious, perhaps the first time you hear about CutEr, is that CutEr, it's obvious once I explain it, CutEr just finds inputs that cause the program to test, to fail. So you cannot take your eUnit test with arity0 functions and start using them because they don't take any input. So CutEr will not do anything on them. You have to have entry points units that take some input, and CutEr finds inputs that cause the program to crash. Okay, so that's actually something that most people don't think the first time they hear about CutEr, that they cannot just take their unit tests and now exercise them, because typically these unit tests are with zero arity. They don't take any arguments. Anything else? Yep.
Have you looked into, so I mean, you mentioned the instrument in the code a little bit in terms of tracing more or less, I guess, but have you looked into actually replacing, let's say, external calls modules, which are folders that select one branch or the other?
Come again.
Have you looked into replacing external calls, for example, that just select one branch or the other, and you actually run the external call, just flip the switch and decide which way to go back to the interesting part of the code?
This is related to some other question, I think. Can you guide the tool towards? And the answer is currently no. The tool has a particular strategy, search strategy. We are working, it's part of the future work, to experiment with better search strategies. We have not looked into this yet. We want to handle full Erlang, and currently the only thing we don't have, well, the main thing we don't have is handling recursive type definitions and maps, but maps are not so commonly used yet. Yep.
How about infinite loops?
There is no issue with infinite loops. The depth guarantees that we are going executions to a point.
Excuse me, infinite loops. I mean, are you integrating the whole program?
We are doing concrete execution up to a depth. I mean, to have an infinite loop, you have to have some branching. You have to go back somewhere, and that's...
Yes, but if you find one input value that gets one function to go in an infinite loop, you will stop it from the...
No. This handles the crashes. You get, you have to have some assertion that's getting violated, or some bad match, or whatever else, there is.
Yes, but this might not crash until you get out of memory for the whole VM.
This might not crash until you get out of memory. These are particular program points where there is some exception happening. We can perhaps discuss it offline. I don't understand what the issue is. Perhaps I'm naive. Yes?
Are you interpreting Bean code, or are you using debugging code, or what? How are you interpreting that?
We are working at the level of core Erlang. So actually, in principle, this could work for Elixir also. Yep. We have no plans of supporting that, but we welcome contributions from users. As a matter of fact, we had to do changes to one file in OTP that does the pattern matching compilation, and we are carrying this around in part of CutEr's code base. So I doubt that it will be so easy to support previous versions. Thanks for the questions.